For the activity regarding to linear motion done on an incline, here's the procedure. Release a ball on an inclined board, sketch and label the velocity time and the acceleration time graphs on the axis in your activity sheet. After you finish the activity, complete the sentence. A ball rolling straight down on an incline has a velocity that is blank and an acceleration that is blank. For the activity regarding to two-dimensional motion along an incline, here is the procedure. For tracing the trajectory, using tape, attach this firmly to one side of this retractable pen to serve as the launching pad. Push the top end and position the object to launch, marble or bottle cup. See the image flash on your screen for your reference. Using a protractor and pencil, mark the bottom left of the illustration board or cookie baking sheet with selected angles at 15 to 20 degree intervals. Tape the illustration board at the top right of the cookie sheet. On the board, select and draw fixed origin at points A and B. The left and bottom ends of the board or cookie baking sheet may serve as the y-axis and x-axis respectively. For your reference, what you're seeing right now is the modified retractable pen mounted with the powder-coated marble at point A, ready for horizontal projection along the labeled inclined illustration board. To complete the setup, elevate one end of the board or cookie sheet using books with an angle of inclination of about 200. Use another book to hold the inclined surface in place. Push the top end of the modified retractable pen and firmly hold it horizontally at point A. Then, carefully place the powder-coated marble on its launching pad. Launch the marble by pushing the clip of the modified retractable pen. What you're seeing right now is an inclined illustration board cookie baking sheet prop between the books for the marble projectile. Trace the powder marked trajectory with the pencil, dust off the powder, and label this path as horizontally launched for later analysis. At point B, repeat steps 3 and 4, but this time carefully launching the marble at selected angles, for example, 150, 300, 450, 600, and 750, and marking the pencil trace trajectories as launched at blank angle. What you're seeing right now on the first image is the marble projectile point B for launching at an angle up the inclined board. In the second image, tracing with pencil the powder marked trajectory of the marble launched at an angle. Take note, the actual projection may not exactly follow the initial angles you selected. At least try to have projection angles close to the angle interval selected. After you finish the activity, answer the following questions. For number 1, describe the trajectory for horizontally far projectiles along an incline. Sketch the trajectory. For number 2, describe the shape of the trajectory for projectiles fired at angles along an incline. Sketch the trajectory. For number 3, compare the locations of the trajectory picked in terms of maximum height reached. For number 4, compare the horizontal distances x range reached when they return to the elevation from which they were projected. For number 5, among the trajectories of projectiles fired at different angles for the same launching velocity, which covered the greatest range or horizontal distance in the x-axis. For number 6, among the trajectories of projectiles fired at different angles for the same launching speed, which recorded the highest peak. For number 7, which pairs of trajectories have ranges that are almost equal? What will happen to the horizontal distances of the trajectory if the board is inclined at 900? That is now totally vertical. For our second activity, regarding to two-dimensional motion on air, here's the procedure. For launching bottle caps horizontally, use the modified retractable pen to launch a bottle cap horizontally 5 to 10 times from the heights of 0.5 meter, 1.0 meter, 1.5 meter, and 2.0 meter. What you're seeing right now is the displacement of a horizontally launched plastic bottle cap from a height. Take note, the place on the floor where the plastic bottle cap lands, measure and record the projectile's horizontal distance from the spot up to the point on the floor that is exactly below the wrist location of the bottle cap. Record as range. For number 8, repeat step 6 and complete tables 4A and 4B. Safety check. Ensure that the trajectories are free from obstructions and the person assigned to launch the plastic cap is tall enough for the 2.0 meter release height. If standing on a table or a chair, assign another member to hold the table or chair in place. Use the table provided in your activity sheet for your observation. After refilling the table, answer the following questions. For number 8, at which height of fall is the average range the longest? How about the shortest? A projectile like the bottle cap moves freely through the air with a constant horizontal velocity Vx and accelerates vertically, the same as that of a freely falling object. The horizontal and vertical position of the horizontally projected bottle cap can be described by the equation x is equal to horizontal component times time and h is equal to 1/2 times acceleration due to gravity times time raised to 2, respectively, where h is taken to be negative. Being a displacement below the point of release and acceleration due to gravity is 9.8 meter per second squared, the times for the horizontal motion and the vertical motions are equal. Complete the table provided in your activity sheet for calculated time fall of horizontally launched plastic bottle cap. After you complete the table, answer the following question. For question number 9, at which height of fall is the calculated time of fall the longest? How about the shortest? In this activity, the concept checks on the horizontal uniform velocity motion and vertical uniform acceleration motion in one dimension should serve as a reminder that all projectiles regardless of its path will always follow this principle. First, the projectiles always maintain a constant horizontal velocity or neglecting air resistance. Second, projectiles always experience a constant acceleration along the axis where the constant net force is directed. There is constant vertical acceleration of 9.8 meters second squared downward or neglecting air resistance for projectiles on air. For projectiles on inclined surfaces, the constant vertical acceleration will be smaller than 9.8 meters second squared down the tilt, which is equal to g sine theta. Third, the horizontal and vertical motions are completely independent of each other. Therefore, horizontal and vertical motion can be treated separately. For the third principle, what can be done to show the independence of two components of projectile motion? Considering horizontal and vertical components separately is important when solving projectile exercises and investigating real-life applications. Congratulations! You are now near at the end of our discussion. To test if you fully understand the lesson, let's have an activity. You will be given a practical task which will demonstrate your understanding. Take note, since we are still in a pandemic situation, you can build your own group being you as the main performer, since you can't be with your classmates. For the performance task, development and demonstration of a volleyball team drill. The goal is to develop and demonstrate a 5-minute team drill that will apply projectile motion, concepts, and principles to the learning and development of 3 motor skills in volleyball. For the role, you are a team of physical education teacher coaches who conduct volleyball clinics under youth sports program of the school. The program targets to entice students who are interested or are still learning volleyball to join the sports clinics, while the trained volleyball student players may assist or officiate drill and lead up games geared towards the development of basic volleyball skills. And for the situation, the school sports program suffered the mass promotion of ball game athletes who recently graduated. To speed up the promotion of renewed interest in ball game trainings and beef up the remaining numbers of ball players, the MAPI teachers came up with the idea to conduct fan sports clinics using modified volleyball games, drills, and lead-up game plans with the others. Starting next Friday, the drills will be used in the weekly sports clinics. These tryouts will give coaches, varsity players, and interested students an avenue to scout, mingle, and develop volleyball skills. For the product, performance, and purpose, you will develop, present, and demonstrate a 5-minute volleyball drill proposal that will apply projectile motion concepts and principles to the learning and development of 3 motor skills in volleyball. Standards. The individual or group proposes ways to enhance sports related to projectile motion. For the criteria for success, the sports clinic participants will rate the proposed volleyball drill game based on the following criteria. First, communication of proposal. Second, physics of sports justification. Third, movement composition. And performance.
That's all for today, Sci folks. See you again on our next episodes, and we'll try to explore, discover, and enjoy life. This is your teacher Richmond. Thank you and keep safe.